Hi kids, we will be going into this paper discussion. You can look at the first question. The circuit in the figure is at steady state before the switch opens. The meaning is potential difference across this is 6, charge is going to be 12. Find the current for t greater than 0. So at t equals to 0, you are opening the switch. By the time this one would have had charge 12. Later on it is going to change. You need to find what is that value. In fact, you can guess from the options. At t equals to 0, it should be 12. Then t tends to infinity, then you can see it will be steady state in this circuit. So anyway, this is the initial scenario. When you open the switch, then charge will keep changing. Now you know when it is steady state, this is going to behave like open circuit, and the voltage, only this will be the closed circuit, and potential difference across this is going to be 4 volts. So V Thevenin is 4 volt. If you want to find R Thevenin, you will short circuit the battery. Then you will calculate equivalent resistance across these 2 points, 60, 60 parallel 30, 30, 30 series 60. So time constant is going to be R into C. Anyway, from here itself you should have understood when t tends to infinity, charge on this is going to be 8. So when you substitute those two, there will be only one option matching. In case if you want to solve, you can write loop equation, or you can draw the Thevenin's circuit. Then you know charge will be varying at this form. Under t equals to 0, charge was plus 12. At t equals to infinity, charge was 8. From there you will be getting the value of A and B. Once you get the value of A and B, you can plug in back. Then you will get charge as a function of time. Now when you divide with capacitance, then you will be getting the potential difference. Now why we are doing that? Because they are asking to find the current in 60. So basically if they ask to find the current in this, so we need potential difference. Potential difference across this is potential difference across this plus this, right? So I am finding the potential difference across capacitor by dividing with capacitance. Then I am finding the rate at which the charge is getting accumulated. So I am assuming current is this way, the rate at which charge is getting accumulated. dq by dt, which turned out to be negative. The meaning is my assumption was wrong. And when I multiply I with R, I will be getting potential difference across the resistor. Potential difference across the capacitor, potential difference across the resistor. Then the summation is going to be net potential difference across this guy. This net potential difference by this total resistance will give me the current in that, right? So they were asking current initially. So okay, they were not asking charge, they were asking current initially and later. So you can find what is the current at t equals to 0, t tends to infinity. Then you can see from the options itself, you don't have to solve this entire thing in case if you just want marks. The figure shows an equiconvex lens of refractive index 1.50 is in contact with a liquid layer on the top of the plane mirror. A small needle PQ with its tip on the principal axis is moved along the axis until the inverted image is found at the position of the needle. The distance of the needle from the lens is measured to be 45 centimeter. Then liquid is removed. So there are two scenarios, when liquid is there, when liquid is not there. So if I talk about image of this point, image of this point is forming there itself. So the rays will be hitting the mirror perpendicularly, then will be retracing. So in this case, if when liquid is there, the rays coming, they will undergo refraction, 1 refraction, 2 refraction, then they will be hitting the mirror perpendicularly. The meaning is they will go parallel. They are parallel rays. Or the other way of saying it is, if I send the parallel rays, wherever they are going to converge. If I send the parallel rays, or let me do one thing, let me say this mirror is somewhere here. Liquid is only thin, and mirror is somewhere here. So I can say there are two thin lens and effective focal length. 30 is going to be, the 45 is going to be effective focal length of the combination, right? So if mirror is not here, if it is here, where there is lens and where is thin lens, this liquid is also going to behave like lens. So if you keep the object here, after undergoing 2 refractions, then the rays will be coming parallel, or else if you send the rays parallel, they will be meeting somewhere here, which is going to be effective focal length. Similarly, when you remove the liquid, again, when you assume the mirror is, suppose if you assume the mirror is here, the rays will be going parallelly and they will be hitting the mirror, or I can say if I send the rays parallelly, wherever they will be meeting, that is going to be focus. So in one case, it is going to be focal length of only lens, in one case, it is going to be focal length of the combination. In one case, only lens is there, in one case lens plus that liquid focal length combination is there. So using this scenario, you will be getting radius of curvature. When you substitute it back, you will be getting refractive index, and that is one very common way of finding refractive index of the liquid. Experimentally, you will be you can expect questions from optics, and I am attaching something below you which you don't have to religiously go into it, but understand there will be questions from optics. At least you have seen in PYQs, there will be some PYQs also here. So anyway, if you are interested into it, you can look into, or else you just neglect this. Two particles each of mass m are connected by massless rod of length L. The center of mass of the system is in circular orbit of radius r about the earth. Calculate the angular frequency for small oscillations. Okay, phi is much less than 1, L is much less than r. So this length is much smaller than this length. So I have attached the other solution also above. So basically, this is very large and this is very small. So when we rotate, this is going to move only by small distance. So we need to see how gravity is going to vary with small distance. Gravity here is gm by r square. So when it is slightly off by distance x, then gravity is going to change by 2x by r. If it was minus x, it would have been plus 2x by r, right? So now when it is making an angle phi, then you can see this is L by 2, this is L by 2. So this is going to be L by 2 cos. So from r, it is going to be extra distance of L by 2 cos. So L by 2 cos, when you substitute L by 2 cos here, then the gravity value is going to become this much. Similarly here, it is going to be nearer, so gravity value will increase by that much. Now apart from that, we need to see oscillations in this frame. So that itself is rotating, so it's better we go into rotating frame. When we go into rotating frame, there will be centrifugal force and other forces, but we can neglect. So when we go with centrifugal forces, centrifugal force on this is in this direction, centrifugal force on this is in this direction, then you need to write torque equals to I alpha about this point. When you try to write torque equals to I alpha, gmm by r square, torque due to them will be getting cancelled, so I am not interested in writing that. Torque because of this thing and this thing, they will be pointing in the same direction, because here it is more, here it is less. Here it is less in this direction, or else you can say torque because of that will be in this direction. So because of this thing, torque is going to be this much, perpendicular distance times of force. Similarly, torque because of this will be this much. Both will be aiding in nature. You can see here this is going to rotate this way, this is also going to rotate this way. So torque equals to I alpha, moment of inertia about this axis is going to be m L by 2 whole square plus m L by 2 whole square. Torque equals to I alpha. Then for small angles, cos theta is 1, sin theta is theta, then alpha is theta double dash. You can see it looks like SHM about theta equals to 0. The meaning is equilibrium scenario is this scenario. From here, when you disturb by small angle, it is going to perform oscillation with some angular frequency which is root 3gm by r cube. A composite spherical shell is made of two materials having thermal conductivities K and 2K respectively. The temperature of the innermost surface is T and the temperature of the outermost is 10 T. The net rate of heat flow from the outermost surface to the innermost surface of the shell. So there is temperature difference, heat will be flowing, it is because of conduction. So you can connect it to current, electricity, and resistance of spherical shell is going to be rho L by A integration. Then these two are in series, so effective resistance is going to be R1 plus R2. So V equals to I into R format. So only that equation we have to write, rest all is calculation. A particle of mass m is attracted to a fixed point O by a force that varies linearly with distance, that looks like spring force. It undergoes orbital motion according to the initial conditions. R of 0 is L and R dash of 0 is that much, and theta of 0 is 0 and theta dash is root K by m. So if I want to represent everything what they have given here, it may look like this. R of 0 is L and theta of 0 is 0, the meaning is angle is 0 with respect to x axis and distance is L. Then r is varying at a rate this much they give r dash, and theta is varying at a, theta may be 0 initially, but it is varying at a rate this much they give. Oh, sorry, root of k by m they give. So velocity you can find, velocity you can find by multiplying with r omega. So omega is root k by m, you can conclude, because this distance is L. So now once you understand this, it tries to go this way. In the process of going this way, this velocity is also going to change. I mean, see, in future it may be going this, see, right now this force may be perpendicular to this, but in future when it goes this way slightly, the force is going to point in this direction, which will change this value. So it is very complex for us to understand, but we can go with understanding force is always pointing towards this. So torque about this point is always 0. So angular momentum should be conserved. Angular momentum should be conserved. Now they were asking about maximum extension and maximum compression. So in case of now, right now we know it is not maximum extension because it is still extending in this direction based on this velocity. So for maximum extension or maximum compression, velocity in this direction should be 0. So let me say it went in some random motion and it was here. So for maximum extension, this velocity will be 0. Or for maximum extension, I can easily write kinetic energy as L square by 2m x square. L square by 2m x square, or else you can write whatever. So velocity in this direction should be 0. So if I do angular momentum conservation from initial scenario to final scenario, angular momentum initially is going to be L into m into L omega. Final angular momentum is x into mv. Now in fact I can write kinetic energy as half mv square. Half mv square I can write it as L square by 2mx square. L square by 2mx square. L I just borrowed from here. Anyway, initial potential energy, it is going to be here like a spring force, conservative force. So initial spring potential energy is this much. Initial kinetic energy is resultant velocity square, half m into resultant velocity square. Final potential energy is this much. Final kinetic energy is half mv square, which I have to calculate from here, or you can write as L square by 2m x square. Now if you look, there is only one variable x. You need to solve for x. You will be getting two roots. One is going to be maxima and one is going to be minima. Then the only option left is about the time period. Now we have talked about this particular scenario. If we don't talk about this particular scenario, if we talk about some generalized situation, there will be velocity along the line joining and perpendicular to the line joining. So in that case, if I write the total energy, it is going to look like potential energy of the spring and kinetic energy along the line joining and kinetic energy perpendicular. Kinetic energy perpendicular, you can always write it as L square by 2m x square. 2m x square, where it is at distance x. Now for maximum extension or compression case, this is going to be 0, so it was easy for us. But in general, kinetic energy will be having two parts when we try to write. One part is going to belong to x dash and one part is going to belong to velocity perpendicular to the line joining. That's the total energy. Now, but this has x and this also has x. So when I group them together and when I show you there is some equation existing like this, I can convince you this is exactly same scenario as some particular guy performing some kind of motion along x axis whose potential energy is given by this term and kinetic energy is given by this term. So if I want to understand what happens to the previous question, I can simply say whatever happens in this question, the similar thing is going to happen there. So suppose if a particle is moving in some potential energy thing which varies like this, whose kinetic energy is at this moment x dash is the velocity. So for this figure I can draw this scenario, for this scenario I can draw this figure. Then I can say here for this potential energy is this much. So if potential energy is varying like this, then for small variation in x, okay, you can see what is first differentiation, second differentiation. When is first differentiation becoming 0? X equals to L. So it will be at equilibrium at x equals to L, which was expected because if you see the previous case, at that moment the centripetal force is, the force towards the center is exactly matching with centripetal force. Okay, so anyway, u double dash. Now u double dash we need to look at when equilibrium scenario x equals to L. U double dash is going to be this much. Then probably would have seen in doubt clearance folder or in the previous exam PDF attached. time period will be given by 2 pi into root of m by u double dash at equilibrium scenario, right, which doesn't match with option C. Now this is the same thing we are going to do in gravitation also. So whatever question they give, we will be getting 3 terms, potential energy plus kinetic energy, but we will group one of the kinetic energy term with this so that it looks like one dimension question for us. Again I am attaching that Taylor's expansion series in case if you want to understand how did time period became. It is depending on u double dash at equilibrium. 1.2 meter cube of air is heated reversibly at a constant pressure from 300 to 600 Kelvin and is cooled reversibly at constant volume to initial temperature. If the initial pressure is 1 bar, that is 10 power 5 Pascal and stuff, the net heat flow and change in entropy and entropy versus temperature curve. So the first question goes like net heat flow. From here to here it is constant pressure process, so heat flow will be NCP delta T. NCP delta T is T naught minus 2 T naught minus T naught. From here to here net heat flow is, it is constant volume, so NCV delta T will be the heat flow. Final minus initial is going to be negative value. Cp minus Cv is going to be R, and N value they didn't give, but we understood by taking P naught, V naught, temperature is T naught. Okay, anyway these values were given, so you can understand N naught, T naught is nothing but P naught, V naught. This value was given, this value was given, which will give you option A. Now if you want to plot T versus S graph, then the only thing what you know is ds is dq by t for reversible process, and it is constant pressure process, so dq is going to be ncp dt by dt, right. Now from here you need to plot the graph. Similarly for the second process it is going to be ncv dt by dt. So I think you need to plot the graph, but you can roughly estimate the slope dt by ds. Slope of this graph is going to be given by dt by ds. dt by ds will be proportional to t. When temperature increases, slope increases. When temperature decreases, slope decreases. From there you can understand that is going to be the diagram you will be expecting. Now they were asking what is change in entropy from A to C. Now what I am doing here is, I could have integrated this. I could have integrated this, I could have integrated this, and I could have added, but I am simply going with isothermal process. If there was an isothermal process which takes the gas to go from A to C, still entropy change should be same because it doesn't depend on the path, it is a state function. So I am, instead of integrating both of them, I am simply taking some isothermal process, some random isothermal process which was not existing in the question, but which takes the gas from this state to this state. The change in entropy in that question and this question should be same. So I will be calculating change in entropy in the question what I was designing, where initial situation and final situation are similar to the things given in the question. So isothermal temperature is constant. In fact it was T naught. Probably I should have written T naught, that is better. Okay, T naught I can take out. Then for isothermal process dq, integral dq is q is nothing but work done in isothermal process, because change in energy is not there. Work done in isothermal process nRT log V2 by V1, where V2 by V1 was 2 here. T naught will go. NR you can write as P naught V naught by T naught, then you can substitute, then you will be getting the answer. Now the same thing you should have got by integrating this and adding them also. In case if you want, you can check, because it doesn't depend on the process, it just depends on initial and final state. Okay, so as we were discussing this question, as I already told, this kind of question it already came in your exam. A uniform thin walled cylinder of radius r and length L and mass m is made of insulating material, carries a total charge q with uniform surface charge density. The tube rolls on the horizontal table and the entire system is placed in vertical uniform magnetic field and gravitational field. The coefficient of friction is given. Determine the maximum value of velocity for which the tube rolls without slipping on the table. And length into the plane is L, and we were already discussing it was like this, it is like this. So and it is going to tip like this. This is what is going to happen. You can see why it is so. So velocity, angular velocity V equals to r omega for pure rolling. There is weight, there is normal, and this motion is complex. So you can always break it as motion of center of mass and motion about center of mass. As magnetic force is going to be Q into V bar cross V bar. When you write V bar as off center of mass and about center of mass, still you can expand them and you can treat them like separately. So if you consider it like motion off center of mass, then every particle will be having velocity in this direction. So V bar cross B bar, every particle will have force in this direction. So it is effectively going to behave like gravitational force only. So you can replace the total force passing through center of mass, which is going to be Q into V into B. Now apart from that, it is rotating. There is motion about center of mass. When it is rotating, then the charge is rotating like this. If the charge is rotating like this, so there will be magnetic moment. Effective current is going to be this much. Current into area, magnetic moment. Magnetic moment is in this direction, magnetic field is in this direction. M bar cross B bar. So the torque is going to be this way, which I have represented like this. This is torque. Understand, this is torque, this is not force. And the force due to that is going to be 0 because it is like a current carrying loop placed in a uniform magnetic field. Due to the motion about center of mass, there won't be force, there will be only torque. Now these are the forces and torque. This is like a couple, it doesn't exert in terms of force, only net torque will be there. Now when I substitute V equals to R omega, its value will be this much. Now you should understand, it is not slipping, so it can't move in this direction. Though magnetic force is in this direction, it can't go in this direction. The meaning is friction should be opposing it, and friction maximum should be greater than this. Friction maximum should be greater than this, and friction maximum is going to be mu into n. In this particular case, n is mg. So you will be getting velocity should be less than this value, less than or equals to this value. Understanding it doesn't slip in this direction. Now similarly, torque is this way. Now you can see this force and this force are trying to rotate it this way. Now gravity will be trying to oppose it. So you will be taking torque about this point in the extreme case. Torque due to normal and friction will be 0. So when these two torques were less than torque due to weight, it is going to be at a distance L by 2 cross mg. Right? When torque due to weight is greater than torque due to this force and this torque, then again it will be not tipping. There will be more points in contact. So when velocity is less than or equals to this. So for not sliding case, for not sliding condition, we got velocity should be less than or equals to this, and for 2 points to be in touch, we got this condition. So velocity should be satisfying both the conditions at the same time. So if suppose we got velocity is less than 5, velocity should be less than 5, and here we got velocity should be less than 3. So the meaning is velocity should be less than 3. It should be satisfying both the conditions. So you should understand these terms look same. I have written it in such a way that you will understand mu and L by 3R. If mu is greater than L by 3R, then this value is going to be greater. So we don't bother about this, only this value makes sense to us. So suppose this was 5 and this is 3. This is 5 and this is 3. Then we will be saying velocity is less than 3, velocity is less than 5, velocity is less than 3 is the one which is satisfying. So if mu value is greater than this, this is what we need to bother about. If mu value is less than this, then this is the value we need to bother about. Now in case of equality, you should understand both will turn out to be same. An X-ray tube operates with a metal target, assume ideal conditions. I think this question you could have easily guessed also. If the acceleration potential increases from V to 2V, then that has nothing much to do with characteristic X-rays, so continuous X-rays only, and that too specifically the energy of the photon, the maximum energy of the photon coming out, the maximum energy increases, so wavelength is going to decrease, minimum wavelength is, cutoff wavelength is going to reduce. The target material is changed while accelerating voltage is kept same, so it has nothing, it doesn't change continuous thing, it changes only characteristic. The position of characteristic lines changes because you are changing the material. In X-ray spectrum, a sharp line is observed whose frequency varies, that is characteristic Moseley's law, right? The filament current of X-ray tube is increased while keeping the accelerating voltage and target unchanged. So basically you are sending more electrons, other than that you are not doing anything. So in that case, intensity of everything is going to increase. Intensity of both continuous and characteristic spectrum increases, but their wavelength remains unchanged. 3 identical smooth spheres of mass 3 kg are kept on horizontal smooth floor and one held together by a light string wrapped around them. The fourth one, identical smooth, is kept on symmetrical on the top of 3, forming a pyramid like structure. Then what is the minimum? Again here also you can get option Q easily. Once you get option Q, you can get the answer also easily. So this was the scenario. When you look from the top, it is going to look like this. Don't worry about the yellow thing what I have drawn. I have drawn just the line joining the centers, bottommost center, so that I can show you this line is parallel to this and this is parallel to this, and the angle between this tension and this tension is 60 degrees. 60 degrees. But concentrate on this top one and this side one. We are going to draw the figure of this, which I have represented using brown. So in that case, when you draw these two, now normal is there, normal is there. Now this normal, this similar normal, there will be from all the three. So normals vertical component, normals vertical component, normals vertical component, 3 normals vertical component will be balancing the weight of this when it is in equilibrium. And if you want to get the angles, I think that you need to do by yourself. It is going to be a tetrahedron. You need to find what is the angle made by the line joining these two with the vertical. So you will be getting a triangle where this distance hypotenuse is 2r, and this distance is going to be, you can see when you join the centers of the bottom 3, you will be getting a equilateral triangle, and this is going to be 2/3 of the height. That is going to be centroid of that equilateral triangle. So once you get this length, then you can get this length by Pythagoras theorem. So cos theta sin theta you know. So 3 times of n cos theta equals to mg cos theta you know. So you will be getting what is the normal from this guy to this guy. I mean the same figure you will be getting, though I have talked about accelerating thing. When it was in equilibrium, normals components will be balancing mg. Then similarly, normals sin theta component should be balanced by these two tensions when it is in equilibrium. So that is going to be T cos 30, normal sin theta component. Now that is in equilibrium. Then when they were accelerating, similarly you will be writing again net force in this direction, mg minus 3 times of normals component equals to mass times of acceleration. Normal sin theta component equals to mass times of acceleration. This normal won't be same as previous normal, so I have taken another notation. And there is a constraint, see generally constraint will be for velocities along the line joining, but as initial velocities were 0, acceleration constraints also going to be the same thing. So this a cos theta should be equals to this a sin theta. Then we need to solve these 3 equations to get small a. You can solve for it because we know cos theta and sin theta values. Okay, so I think that's a very straightforward question. They have given some information. Let me read out the information. Let me round off everything whatever we'll be using. Okay, rated powers were given. So if I take this is 0 volt, this is 0, this is 0, this is 0, then this is going to be 9 volt, 45, so this is current is going to be 5. Similarly, this is 24 volt and power is given, so you can get the current. If this is 20, this is 20. Then 60 milli and 50 ohm, so 60 milli and 50 ohm. So potential difference is going to be 3. Anyway, if this is 24, this is going to be 24. So there is 3 potential difference. So this is going to be 27. So battery value you can get. Then out of 60, 20 is going here. So this is going to be 40. Out of 40, 5 is going here. So this is going to be 35. Then apply V equals to IR across this, V equals to IR across this. Then you will be getting R1 and R2. Right. Then I think they were talking about power also. That is also power utilized by this, power delivered by the battery. That is going to be EMF of the battery times of current. The maximum value of V of t in RLC circuit. Again, we have been doing this in the paper discussions. By this time you should have got used to this. So wherever inductance is there, you can replace with J times of XL minus J times of XC, and you can treat it like normal current electricity equation. You can write loop equations and you can solve, or else I can say this thing is in these two are in series, which is in parallel with this, which is in series with this. So these two are in series, 1 plus J, that is in parallel with minus J. Then that is in series with 1. When you do we will be getting Z value something like this. Then again current is going to be EMF by Z value, EMF by Z value, and so current if I know, then if I want to find a potential difference across this, I can multiply with what is the equivalent resistance kind of thing across this, that is this value, which is minus J plus 1, right. So anyway, we understood when this becomes maximum, this is going to become maximum here, or else we could have written it like complex number again. That's okay. So you need to calculate what is this magnitude, which is going to be 2 root 10. A hydraulic lift of the type commonly used for greasing automobile consists of 280 mm diameter, this thing which slides under 280.18 mm diameter. So this diameter is 280, this diameter is 280.18. So this gap plus this gap is 0.18, this gap alone is 0.09. Okay, and this is moving with some speed. Specific gravity is given. Now you should see what are the dimensions of this. This is meter square per second, this is meter per second. Find the frictional resistance when 2 meter of the ram is engaged in the cylinder. So roughly speaking, in viscosity there are only couple of formulae which you have to use. So you will be using that. Eta value they didn't give. Eta dimensions you know those dimensions will be coming only when you multiply density with kinematic viscosity. So basically eta is going to be product of those two. Then this radius is R1, this radius is R2 I have taken. So how much surface area entered? It is 2 pi R1 times of L, 2 pi R1 times of L, and dV by dr calculation is not very easy generally. So we will be roughly going with V by R2 minus R1, because this velocity is there, this velocity is 0. We are assuming it is linearly increasing. As the thickness is small, that linearly varying assumption is okay. So when you do the calculation, you will be getting something. Now I am attaching a question below this, where you will be understanding how you will be finding the velocity profile exactly for general scenario when the thickness is not very small. The following deuterium actions, reactions and corresponding reaction energies Q are found to occur. Okay, so they have given something from here. They were asking what is the Q value of the reaction. So they were talking about these reactions. They were saying nitrogen plus deuterium is going to combine and give you proton plus nitrogen 15, then the next one, then the next one. They are asking what is the Q value of the reaction. They gave the Q value of this reaction. The meaning is this mass is more, this mass is less. So initial energy is more, final energy is less. So energy is released. That is the reason Q value is positive. So this mass minus this mass into C square is going to give you Q value of the first reaction. Second reaction, this mass minus this mass into C square, this mass minus this mass, this mass minus this mass. So now when you add all those four equations, you can understand these are always associated with positive quantity, these are with negative quantity. So you can see this nitrogen mass is going to come as positive as well as negative. So they will be getting cancelled. When you write this mass minus this mass into C square, similarly for all the four equations, and when you add them, the common things which are, I cancelled them here. So you will be getting, this is 3 times and this is 1 time, this is 1 time, this is 1 time, right. So that is the mass difference from here to here into 931. That should be giving us Q value of this plus Q value of this plus Q value of this plus Q value of this, right. Thereafter it's only calculation. A homogeneous, smooth, thin, sufficiently long rod of mass m and length L is in a state of weightlessness in a deep space. A small bead is threaded onto rod. The bead has mass m. You can see that mass is much smaller than capital M. So you can assume capital M is almost not moving. If the time period of small oscillations of the bead near the center of the rod. Now you see here, when you slightly disturb it, when you slightly disturb it, this part of the rod is similar to this part of the rod. This part of the rod is similar to this part of the rod. If this distance is x, right, if this part of the rod is similar to this part of the rod, where this distance is L by 2 minus x, this is L by 2 minus x, so this is 2x. If this is small, then this is going to behave like a point mass. Now I have exaggerated it. When the x is very small, then you can see this 2x is the extra thing. Other than that, it looks symmetrical. So extra force on this is because of this 2x length. That's the only thing you should understand. Then you straightforward write net force equals to mass times of acceleration. When you move it slightly by distance x, there will be an unbalanced force because of this 2x. Then that force equals to mass times of acceleration. Now the distance from here to here is approximately L by 2. Force equals to mass times of acceleration, then it looks like SHM, then you can calculate the time period. A metal rod of length 1 meter is clamped at 2 points as shown in the figure. Distance of the clamp from the two ends are 5 cm, 15 cm. The minimum natural longitudinal oscillation of the rod. So they were asking frequency at which there will be natural oscillation. So basically generally we'll be treating this question as 3 parts, where we will be taking this as one part, this as one part, this as one part. When will this will be under natural oscillation, this will be under natural oscillation, this will be under natural oscillation, or when will resonance happen for this and for this. Now we treat them like 3 different questions, then we understand the frequency for which there will be resonance here is the common frequency for which this guy independently is in resonance, this guy independently is in resonance, this guy independently is in resonance. So the first thing is we will be calculating velocity of longitudinal wave. Velocity of longitudinal wave is root of y by rho for in solids. Root of t by mu is velocity of transverse wave. Velocity of root of b by rho is in liquids or in gases kind of. This is for solids. Longitudinal waves for solids. Then in the first case, this is going to be node, antinode, a displacement. So odd lambda by 4 should be equals to L1. This is node and node displacement node. So it is going to be even lambda by 4 equals to L2. Similarly, odd lambda by 4 equals to L3. From there you will be getting for what all frequencies this guy independently will be in resonance if I take him separately. For what all frequencies this guy independently will be in resonance, Then the common frequency is going to be the resonant frequency when the structure is like this. So we need to see what is a common frequency. This will have certain values, this will have certain values, this will have certain values. When will these 3 be equal? For that you should be easily understanding this should be even number. So this and this also should be even number, and in fact this is 40,000 into some odd number, this is 40,000 by 3 into some odd number. From there you will be expecting that odd number to be multiples of 3. Anyway, a quick guess can show you like when this is 1, this is going to be 3 and this is going to be 16. So 40,000 is going to be the frequency for which it will be under resonance for the first time. Narrow parallel glowing gas filled tubes in a variety of colors. Okay. Adjacent tubes are 2.44 centimeter apart. The tubes forming one letter are filled with neon and radiate predominantly red light with a wavelength this much. Another letter, it is blue light. Then pupil diameter is given. The viewer can resolve the separate tubes of one color but not the other. So basically from here you should be understanding they are talking about resolving power and stuff. So when can a person resolve one color but not the other color? So once you understand it is related to resolving power, I am attaching the theory related to that from H.C. Verma. So that angle we will be knowing from that theory, it is going to be approximately 1.22 lambda by A, where A is the diameter of the pupil. So you will be getting, if there is one point here, its image will be some kind of disc. This image also will be some kind of disc. Now when they come closer, they are going to overlap, and after that you can't find, if they overlap then you can't say they are resolved. You don't know the difference between those 2 points. When this image and this image are formed like this, then you can understand they are 2 different points. So that angle 1.22 lambda by a. So you can see this length is almost d into theta. Okay, so leave this. So we know this angle, we know this distance. So what should be this distance such that it will be just resolved? That is going to be d theta, where theta is 1.22 lambda by a. So if the distance is more than that, then it is well resolved. Forget about this, it's not. Okay, I think this distance was given. Okay, this distance was given, then they were talking about what should be the distance between these two. So when you keep coming closer and far away, then it is going to change. Anyway, this is the only equation you have to write. After that, they have given some values, you will be substituting. So d into lambda should be less than or equals to this thing for him to able to resolve. But lambda lies between 390 to 650, or 390 and one is 390, one is 650. When you substitute lambda is this much, you will be getting d value of one thing. When you substitute lambda this much, you will be getting d value some other thing. So the meaning is when the distance between them lies between these two, then he can resolve only one color, he can't resolve the other color. The gap when you subtract, you will be getting the required answer, right.